Cool. So the next rigid motion or rigid transformation that we are going to be looking at is called the translation, and it is also called a slide, because what you'll notice is we're going to move this triangle EFG along the paper using vector A as our kind of measurement tool to see how far along the paper we're going to slide it or translate it. And what you're going to see after we do it is something that looks like this. You can see how every single one of the points here that corresponds E to E prime, F to F prime, and G to G prime, they are all the same distance away from each other, and that distance is exactly the same as this one right here, the distance of the vector itself. All right, so, and you can see how G to G prime, F to F prime, and E to E prime, they are all that same distance. So let's go ahead, I'm going to show you how this works and how to do it, and we're going to employ some logic here. All right, so the book and other sources may also have this as a line segment. So in this case, I'm going to call it line segment AB just to make it more clear, but it could also be vector A, and that would be another way you might see this talked about. So I'm going to set my compass to AB, all right? First thing, I want to find out a bunch of different possible places where, all right, that looks pretty good, I went through right there. A bunch of possible places where point G prime, F prime, and E prime might be. So these are all places I suspect I will find those 3 points, all right, on somewhere on each one of these arcs, all right? And I guess I can label it, all right, just for the sake of clarity. I'll call this the F arc, the E arc, and the G arc, all right? If that helps you to do that, great. You can go ahead and erase it afterwards, all right? But that might be a good way to organize it for yourself, all right? So I know that E, F, G prime are all going to be somewhere on each one of those arcs. Now let's figure out a way to figure out exactly where they are. The first thing I'm going to do is I'm going to measure the distance from the beginning of the ray, or point A here, to point G, all right? And this is a bit of a small measurement here. I'm going to do my best here. Let me actually move my compass. If you ever have this problem, it's too small, move the compass pencil up a little bit. All right, that might make your life a little easier. And there we go. Actually, that is pretty perfect now. So when I go over to point B and I arc from here, I'm going to find the place on that G arc where G prime has to be. All right, so again, what did I do? I took the distance from A to G, and now I'm going to take that distance from B, or you could even look at that as A prime if you want, but B to G, the G arc, and there we have it. There's my G prime. So we have 1 point, which means we have them all right? Once I know point G prime, I can stretch my compass from G to F, measure that, wow, that was perfect, measure that exactly there, and take my pin to G prime and arc right there on the F arc we just made before. That's going to be F prime. And I can also take that distance from G to E, and sometimes it's helpful just to draw a little arc. All right, yeah, see, like that one looks like it might be just a little too far, so let me bring it in a little bit. That's better, cool. So I drew my little arc to make sure it was the right distance. Now I've got E prime. And what I've been able to do effectively is move triangle EFG along line segment AB, translating it across the page, so across the plane. Let me go ahead and that one looks good. And this looks good. Let's do that. And oh, see, that's why it's good to do that. Just double check it. Cool. Looks like I have effectively been able to translate EFG along vector A, or line segment AB, to create the image E prime, F prime, G prime.